Hello and welcome to another video on orbital mechanics. I am still working through the book Orbital Mechanics for Engineering Students by Howard D. Curtis, 4th edition. And I am up to question 2.30, and 2.30 is very similar to problem 2.24. So I'm not going to do that one. Problem 2.31 is a little bit different, so I will go on to that one. So 2.31, for an Earth satellite, the specific angular momentum is 70,000 kilometers squared per second, and the specific energy is minus 10 kilometers squared per second squared. Calculate the apogee and perigee altitudes. So we're given our angular momentum, h equals 70,000 kilometers squared per second, and we're given the specific energy, which is minus 10 kilometers squared per second squared, and it wants us to get the apogee and perigee altitudes. So to do this, we can use an equation for specific energy, which is this. Specific energy equals minus a half mu squared over angular momentum squared upon 1 minus e squared. So we can just simply rearrange this, and we end up with E equals square root of 1 plus 2 energy h squared over mu squared. And when you work that out, you end up with eccentricity equal to 0.619, and then if you use that in the radius equations, r equals h squared over mu upon 1 over 1 plus e, that's for apogee, and perigee, and then our apogee equals h squared over mu upon 1 over 1 minus e, and that one equals 1.2149 by 10 to the 6, and this one is equal to 2.5889 by 10 to the 7. Yep, that's 2.31. And then 2.32 is also pretty much the same as 30 and 24, so not going to do that. And then 2.33 is interesting. 2.33 is asking if the perigee velocity is c times the apogee velocity, calculate the eccentricity of the orbit in terms of c. So there's a couple of ways of doing this, but the way I did it was to go with the equation velocity equals mu over h upon the square root of 1 plus 2e cos theta plus e squared. Now at perigee this is plus 1, and apogee it's minus 1, so velocity perigee equals mu over h square root of 1 plus 2e plus e squared, and the velocity apogee equals mu over h square root of 1 plus 1 minus 2e plus e squared. Now these are interesting because these actually break down into that's 1 plus e And because that there is 1 plus e squared, and that's the square root, so it just becomes like that. This one is 1 minus e, right? Square root of 1 minus e all squared. So that's VP, that's VA. And it says in the question, perigee is C times apogee, so VP equals CVA. So then that is, so this is times C, right? No, sorry, that's not right, sorry. It's CVA equals mu over H 1 plus E. That's, so it's C upon mu over H 1 minus E equals mu over H 1 plus E. These cancel. So then we have C minus CE equals 1 plus E. C minus 1 equals E plus. Okay, where was I? Sorry, I just got interrupted by a phone call. So we were here with C minus CE equals 1 plus E, C minus 1 equals E plus CE, C minus 1 equals E upon 1 plus C, and then C minus 1 equals 1 over 1 plus C equals E. And that is the answer that is given in the book. So that is everything on elliptical orbits finished. There's about another 15 questions in this chapter. Can't wait to get through them all and get on to chapter 3. If you have any questions or you think I've made a mistake, let me know in the comments, and I'll leave the MATLAB in the description. Thank you very much. Goodbye.